Hello and welcome to today's webinar. Today we're going to be talking about cellular IoT and the benefits that it brings in LPWAN applications or low power wide area network applications. I'm your host for today. My name is Tiago Montt and I'm a developer market manager here at Nordic Semiconductor. So the agenda for today's webinar. First, we're going to look at the landscape for LPWANs or low power wide area networks. Then the largest chunk of time will be spent on this section here. So considerations that you need to have when you want to select an LPWAN technology for your IoT application. So within that, we'll talk about some of the benefits that Cellular IoT brings as an LPWAN technology and also some of the misconceptions that exist out there that are good to clarify, so you have better visibility about those benefits. Then we'll talk about some key application segments for Cellular IoT. We'll go through Nordic's cellular solution, and we'll then wrap up with the Q&A at the end. Okay, so let's start then looking at the technology landscape for LPWANs. So you have a variety of technologies within this space. Some of them are very niche, so very oriented towards a specific use case, and others are a little bit more generic. They can be applied to various use cases. And we're sort of trying to plot them here in terms of power consumption and in terms of throughput. So starting here on the top right, you have the high throughput technologies, the technologies that we use, for example, in our mobile phones. So they have high throughput, but they're also not low power, which means that they will, of course, drain your battery quite fast. So they're not suitable for low power IoT applications. Then we have the more legacy technologies, 2G and 3G, which are reaching end of life. They had, let's say, medium throughput, and they were also not something you could consider low power. Then if we move over to this low power part of the chart, on the lower throughput spectrum, you have a variety of sub-gigahertz technologies operating in the ISM band, which is unlicensed. Things like Sigfox or LoRaWAN fit into this part. And then on a bit higher throughput, you have the newly introduced DEC NR Plus that Nordic is also supporting. DEC NR 2020 is another name that you might see this one going by, which is the technical name in the specification. And then you have the cellular IoT technologies, NB-IoT and LTE-M, which offer quite capable throughputs while remaining low power. One thing to take away, because we're going to come back to this during the presentation, is that cellular IoT operates in the licensed spectrum, whereas sub-gigahertz technologies such as Sigfox or LoRaWAN, as well as DEC NR Plus, they operate in the unlicensed spectrum. So this one, there are a few different ISM bands where these operate, and then DEC NR Plus can operate on the 1.9 gigahertz globally unlicensed band. So when you want to select the technology for an LPWAN technology for your IoT application, one thing is clear, is that you don't have one size fits all. So there's going to be a variety of factors that you need to consider. So you'll have to balance both business and technical requirements, and some which actually cut across both domains. Another thing to keep in mind is that very often these LPWAN technologies or the LPWAN applications, they are designed and meant to be out in the field for very long periods of time. So we're talking 10 to 15 years lifespans, which means that you need to plan for future growth, because something that is suitable today might not be suitable tomorrow. So your needs within that time span may evolve, and that's something you really need to keep in mind, making choices that will be valid throughout the lifetime of your device. And last thing to highlight on a high level is that there's multiple layers to cost. And often you can see when you're comparing technologies, you might see that on certain specific data points, whether it's hardware cost or data cost, there might be a difference between these. You really need to look at the overall pie. You need to look at the total picture and do a proper calculation of your total cost of ownership, or TCO. because that will include all the factors that will tell you what is the cost of this technology and how expensive is it to deploy my IoT devices. So let's go through these one by one and try to dig a little bit more into them. So let's start then with the data rate. So data rate is essentially just one data point, and it might not tell you the whole story. You might need to do a bit of translation into how this works in real time. So if we just do sort of a blank comparison of max data rate between a few of these technologies. So we have LTE-M that is the most capable technology when it comes to max data rate, giving you 300 kilobits per second of downlink and 375 of uplink. So uplink being from device to the internet or gateway, whichever that may be, and downlink being the other way, so from gateway or from the internet down to your device. Then we have NB-IoT, which has evolved over time. So NB-IoT, that was introduced in 3GPP release 13, had 30 kilobits per second for downlink, 60 for uplink. NB2, which is in 3GPP release 14, has increased that significantly. So we have 127 kilobits per second of downlink and 169 of uplink. And then we have some of these unlicensed technologies, for example, LoRaWAN, 27 kbps on both downlink and uplink, and Sigfox, a bit more modest data rate figures here, 600 bits per second of downlink and 100 bits per second of uplink. Just to point out that, and we're going to talk about Nordic's products and hardware products a bit later, is that our existing product that's been in the market for the longest, the NRF9160 SIP, that one supports 3GPP release 13 with a few selected features on release 14. But the newer devices that we have recently launched and announced, the 9161, 9151, and 9131, they are fully compliant with 3GPP release 14, which is the release where you would get these improved figures for NB-IoT, NB2. So, like we mentioned, data rate is one piece of data, one data point, right? And essentially, that gives you just a representation of the capacity at which you can transfer bits from your device over the radio interface to some other device, whether that's a gateway or a base station. And that's really what it is, because then you have to consider that there might be other limitations. And coming back to this point about licensed and unlicensed technologies, one of the challenges with unlicensed technologies is that, yes, you do have this measurement of capacity, but the question is, how long can you actually sustain it? And what you'll find is that many of these technologies have limitations that will affect the actual data throughput. So how much data can you actually move out of a device over a long period of time? So you'll find limitations when it comes, for example, to duty cycle, to payload size. So you can only send smaller payloads, which of course means that there will be more overhead from protocol, for example, that won't be diluted over larger payloads. Or you can have also limitations in, for example, number of messages, within a given time unit, whether it's an hour or a day or something like that. One example is Sigfox, for example, even though it has 600 bits per second or 100 bits per second of data rate, it actually has a maximum of messages that you can send a day. And if you compute that with a maximum payload you can get on each of those messages, it means that you can send or uplink a maximum of 1,680 bytes per day, which can be a bit limiting depending on the use case. An analogy for this is like, you have a highway, it has a certain capacity that you can put cars in it, but then you have traffic lights. So it means you can only put cars into the highway at certain points. And it's just, standing there without actually that capacity being used on a continuous basis, let's say. And the other thing to consider when it comes to data rate is that you need to look at all the use cases, everything you need your IoT device to do, so you don't have, unpleasant surprises later down the line. So it is true that, very often the primary use cases of your device will be fulfilled quite well, even with low data rates. Things like you have a sensor, you want to read it periodically, once an hour, even once a day. Yes, you can have low data rates. They will perfectly fit into the use case. but modern IoT devices may have other requirements. A good example is firmware over the air, or FOTA. At least at Nordic, we do consider this feature to be a must-have, and we do see that it's becoming very ubiquitous in modern IoT devices. So this means that you have to move a large chunk of data from a cloud backend into your device, so you can update the firmware on your device. And if you don't have the data rate capacity to meet this need, it means that it's going to take a long period of time, and will also be very draining on your battery, because you'll have to have the radio operating for longer periods as you receive these firmware bits and pieces in chunks. And of course, it takes longer. And if you're using FOTA, for example, to mitigate the security issue, you do want to be able to update these things as quickly as possible and not have to wait days or more to get your devices to be updated. Then when it comes to, a bit on the life cycle and maintenance of your device, ideally you'll want to be able to maintain them remotely. So you want to do remote debugging, which means you might want to have the capability to, for example, extract the logs from your device, so you can look at what's happening and try to understand the misbehavior, introduce fixes in your source code, and get a new firmware deployed with FOTA as quickly as possible. And there might be then a variety of updates out there that you need to do. For example, if you think about security, you might want to do rotation of credentials or keys, or just reconfigure your device based on needs, based on the use case that you might need to move significant amounts of data into your device for configuration operation, as an example. So, the key message here is that take data rate, don't take it at face value, because that just only tells you one part of the story, and really think about your use cases. Think about what you need throughout this long life cycle period of your device, and make your selection, find your balance based on all those considerations. Then the next topic to discuss is battery life, which sort of translates into power consumption or energy consumption, which are a little bit different things, and we'll talk about them here. So if you search about cellular IoT, you might see these statements that in cellular IoT it's high power consumption because devices are always connected. And this might not mean what you think it does, because it can often be interpreted as that you have the radio being active all the time, and that's not exactly the case, because LTE-M and NB-IoT introduce mechanisms that, yes, do keep devices connected to the network, but they can actually be in a sleep mode for extended periods of time and reduce this radioactivity to what is actually needed by the application. I think this is also a bit biased by, let's say, our common knowledge of how we've been using traditional cellular, in our phones, which we need to charge on a daily basis, and it sort of makes us jump into this conclusion of permanent connectivity. And when we're talking about IoT devices, whether it's LPWAN or any other technology, if you want to optimize for battery life, that from a high level and a bit simplified view, is that it means two things. You need to stay in a sleep mode for as long as possible. So don't use the radio. Coincidentally, being IoT, the best way is to use the radio as little as possible. And then when you do send data, if you need to do it, as much data as possible, so you sort of reduce the overhead that you send each time you exchange data, use the radio, and as infrequently as possible. So you can then reduce that protocol overhead that you'll find in essentially any wireless communication system. And LTE-M and NB-IoT have introduced two features that meet these goals that I mentioned on the top. So the long sleep modes and sending as much data as possible. Power saving mode, or PSM, and the extended discontinuous reception. So looking at these from a overview standpoint, so power saving mode, this is when you have a device and you have at least, or it's indicated or suggests, let's say, for devices that have at least 10 minutes of latency between data transfers. And you can sleep for much longer periods. By the spec, you can do up to 413 days. And this gives you, this means that you can spend long periods of time where your power consumption is essentially just the PSM floor current on the NRF 9160 as an example, which is under 3 microamps. So what this means is that you can, if you consider your use case, and yes, it is true that when the radio is active, you will find that the peak currents can be high, and they will be higher than other LPWAN technologies. But really what matters here is the average. And because sending data through Cellular IoT is so much more efficient, you send the data in larger packets, faster out of the radio interface. You can actually spend more time in a sleep mode, and your average power consumption will be comparable to other LPWAN technologies. And then we also have the EDRX, so the extended discontinuous receive. And this is one when you want to, send data a bit more often. So when you're looking at maybe less than 10 minutes latency. And the intervals are a little bit smaller. And then you have a little bit higher floor current as well. So just under 5 microamps. So, but also, as you can see here, there is flexibility. So depending on your use case, depending on the needs of your product, you can choose the most suitable sleep mode and then find that balance between power consumption and latency on your application. All right. So moving on to the next factor that you will want to consider, which is reliability. And here we can, make a strong statement that, cellular IoT is really unmatched when it comes to reliability. And the key reasons are, and again, I mentioned this is important, cellular is operating in a licensed band. And what that means is that because you're operating in this licensed spectrum and you have to have your devices certified with carriers and following global standards, it means that your device is operating in an interface-free environment, which gives you predictable communication between device and the rest of the world. Then the other thing is that cellular networks, they are built for redundancy. They are built for high reliability and redundancy. So you have backup systems in place, and the goal is, of course, to ensure continuous connectivity so that your device will not lose connectivity to the carrier. They were also built with quality of service in mind. So that has always been a priority for cellular networks. And that's something we can all attest to as consumers using this in our mobile devices. And it's one important thing about this is that on cellular, you get assurance that your message will get delivered as part of the standard, and also low latency. And this is important because in many LPWAN technologies, the standard, the part of the LPWAN which is standardized, does not cover the reliability piece. So you need to handle the reliability, sort of knowing whether your message was received or not at the application level. So this brings more complexity into your application code instead of sort of focusing on the differentiation of your product and leaving the transport piece and the communication piece down to the firmware and the cellular modem. And the last part, but certainly not the least important one, is security. Security is an absolute, cornerstone of IoT. If we all wish for IoT to scale, it needs to be secure. And the reason why we're all carrying mobile phones in our pockets is because it's based on secure cellular networks. If security wasn't there from day one, I'm sure that we probably wouldn't be using our mobile phones as much as we do today. And that the nice part here is that, of course, the cellular IoT technologies, they leverage the existing mechanisms that have been in the field for decades. They've been proven for decades of all these cellular deployments. So all of that is leveraged for cellular IoT, which means you have very robust security for your IoT devices. And then when it comes to coverage, as a user, you know that wherever you go in the world, you will probably have mobile phone connectivity. So it means that there is global and virtually ubiquitous coverage for cellular. So there's extensive global coverage. Cellular networks have been rolled out for decades, and they continue to be expanded, improved, maintained. There's always investment flowing as new standards roll out. So you're all expecting this to increase over time. You will find, of course, coverage in both urban and rural environments, which means that you don't really need to have any concerns about the infrastructure being in place. and also indoor and outdoor. So cellular signals, they have pretty good penetration into indoor environments, into buildings. So you'll have indoor coverage if you deploy devices inside homes. There's some slight differences. We won't go into details in this presentation, but NB-IoT has better penetration than LTE-M. So if you have devices which are located at sublevels, for example, below ground, NB-IoT will be a more suitable choice. Think of a water meter or electricity meter on a basement. NB-IoT would be a more suitable choice for that. But all in all, there's indoor and outdoor usage, so which means that coverage is not a concern for Cellular IoT. And then another area, another factor where Cellular IoT does bring benefits is mobility. So it kind of couples back to the coverage. So you have cellular networks and infrastructure pretty much everywhere in the world, and roaming between what cells or operators have is part of the specifications and part of the standard. So it's not something you need to be concerned at your device level, at your application level. All of this will be handled on your behalf, which means that the big benefit here is that if you have devices that need to be deployed globally, and you're expecting them to move across country borders or even across continents, then Cellular IoT is really the best solution for you because it brings you all those advantages. So that's something you don't need to be concerned about. And it's a big difference when you compare to other LPWANs that have prioritized power efficiency when they were starting to be created. And that, has put some limitations on mobility. That requirement has come a little bit later. So you have some, movement limitations with other LPWANs. What that might mean into your end product is that if you have a product that you want to sell in different countries, because of this limitation and because of, some LPWANs do have what you could call an operator, but you won't find operators that operate in multiple countries, so that you have this sort of seamless mobility. So what might happen is that you have to manufacture products which are specific to certain countries, so which gives you a sort of long list of SKUs, and it makes your whole logistic operation a little bit more convoluted than what it would need to be. So essentially, what Cellular IoT offers is really a no compromise solution. It's because you get the low power benefits, so the low power consumption, and you have the mobility built in as two things that go together without any concerns. And that makes it ideal for asset tracking applications. We'll discuss that a little bit later. And also where you want to have global deployments. So you can have this benefit of streamlining your manufacturing and your logistics with unique SKUs that you can then sell anywhere in the world. Then when it comes to interoperability, so the key thing is that Cellular IoT adheres to global standards. So these are set by the 3GPP and other organizations. The goal is really to ensure interoperability, that devices will move around across networks, across carriers, and they will just work. Behind this, of course, you will have very strict certification processes. So meaning that vendors like Nordic, we have our hardware and software, specifically the modem firmware, they have to be certified with various operators worldwide. And the goal is to ensure quality, to ensure that you take a solution from Nordic, it will work with various operators in various regions of the world. So that's not something that you as a customer need to be concerned with. Another thing that is really important is that with Cellular IoT, you have native IP connectivity. So you'll have just direct access to the internet without any kind of bridges or gateways, which can introduce security issues, because if your data goes through a gateway that you don't have control over, there's always a risk of eavesdropping on your data. But on the case of cellular, building on top of the security that it has always been there, you have this direct connection, so you can do direct IP support. And this gives you predictability that your device will operate as you expect them to operate, and that will be regardless of what location you are in the world, what carrier you're using. One example is firmware over the air updates. So of course that part will be depending on the vendor, it will be done on a specific way that your system will need to implement. But when it comes to getting that data from your cloud into your device, it doesn't really matter which carrier you're using. And this is in contrast with some other LPWAN technologies that where photo is not fully defined, and sometimes you have variability on the network and the configuration. And this is one of the key reasons why often customers using different LPWANs, they have to deploy their own infrastructure to make sure that there is, they actually have a standardized process, or at least within their products, a standardized process for things like photo. And then moving to scalability. So Cellular IoT was built for massive IoT. So devices can be connected anywhere, anytime. It, of course, a big benefit is that it's leveraging existing infrastructure. And when it comes to a bit more detailed data here is that each base station can support about 50,000 nodes of LTE-M or NB-IoT devices. And for you as a customer, if you want to scale your deployment, that means you just need to add more devices, right? You don't need to worry about any kind of infrastructure investment. So you putting your focus on the differentiation of your product is really what you can do there, and you don't have to worry about rolling out and maintaining infrastructure. I would you sort of make a comparison. For example, if you're developing a web application, you're not going to build a browser for it. So you're going to build on existing infrastructure, existing browser infrastructures, or browser applications, existing ISPs. You're not going to do any of that. You just stand on the shoulders of giants, as it's someone sometimes said, and you'll just add your differentiation there and not sort of reinvent what's underneath, because that doesn't add differentiation and value into your product. And of course, as more devices reach out into the field, there will be benefits from economies of scale, because the cost of hardware, software, everything, data services will decrease over time, making these products and deployments more cost efficient. And now moving on to cost. So this is really the part that is important to highlight, that cost is not, the cost of the hardware or the cost of the software element. It's really multiple layers that you need to look at before you can reach a total cost of ownership figure. And often the first comparison the customers make is, okay, they look at Cellular IoT and they look at some other LPWAN and they look at what is the cost of the hardware, right? Is it a transceiver or sort of a more integrated solution? And sometimes there can be differences there, but that doesn't mean that your overall cost is going to be lower just because the hardware is less expensive for a particular choice, because you might have costs hiding somewhere else. The other thing is that keep in mind, again, that infrastructure, most likely it's not your core business, right? So you don't want to have to bear the responsibility for rolling out and maintaining infrastructure. Often you might find barriers that you're not even expecting. For example, if you want to have an LPWAN deployment with your own gateway infrastructure in an office building, I'm sure your IT department will be very interested in what kind of security risks or backdoors that might introduce into your system, because of course those gateways will have to have internet connectivity using your office network. So there's many things that you need to consider that might come as a surprise. So overall, if you're adding infrastructure, it will bring unpredictability to your business and may impact growth, because every time you want to roll out into new areas, you need to also deploy the infrastructure there. So it kind of limits your ability to scale. If you rely on third-party infrastructure, often in some LPWANs, you have sort of community gateways that you have absolutely no control over. So that introduces risks that you may or may not be willing to accept. So that's something to keep in mind. Cellular operators these days are offering more and more IoT tailored plans. So that means that the cost of data is going down. And of course, it's also the price for, let's say, peace of mind of not having to worry about the infrastructure. And the other thing that's a little bit hiding in plain sight is that in today's market, especially within IoT, time to market is really important. So getting to market with your products before your competitors is important. So you really want to look at a solution that just works out of the box. You don't have to worry about, it will just connect and it will do what it needs to do. The business side of it, and let's say the business logic, the application differentiation will be ready to go, because you don't have to worry about the underlying connectivity piece. And the last part to mention when it comes to cost is that devices, LPWAN devices, typically have long life cycles. We're talking 10, 15 years out on the field. So you want to make sure that you can maintain these devices in a cost-effective way. You can deploy FOTA, you can do remote update without having to send specialized technicians to the field to maintain your devices, because that will also be costly. So this is something to keep in mind, not just the sort of upfront costs of developing and deploying them initially, but the cost of keeping them active for the the sort of the time span that you want them to be operational. And therefore, all being said, it's easy to conclude that Cellular IoT is the most future-proof solution when it comes to data rates, battery life, power consumption, reliability, coverage, mobility, interoperability, and scalability. So LPWAN applications typically designed for long periods of time out in the field, 10 to 15 years. So you really want to choose a solution that ensures that you have connectivity throughout that period, that you don't have disruptions, and that can meet that balance between technical and business requirements, not just at the beginning, but throughout that whole lifespan. And Cellular IoT, they have a history of reliability, stability, security piece is really important, and it makes for more predictable total cost of ownership, because you know the cost of the hardware. You can better estimate the cost of development because you abstract the connectivity away and you focus on your application. With subscriptions, you know how much you're going to pay because you don't need to worry about infrastructure. And of course, on the maintenance side, if you can do things remotely, it will also make that calculation a lot easier. So we went through Cellular IoT within LPN, sort of the benefits of Cellular IoT and various factors, business and technical factors. And let's look at some of the most important applications where Cellular IoT really brings a lot of benefits. So the first one is asset tracking. So essentially, you have an asset, it has value, you want to track it anywhere, anytime. Smart cities, essentially digitalizing our cities and our urban environments. Smart metering, so the ability to extract data from a variety of meters, so that you don't need to, for example, deploy technicians to go in and make the reading. And then a lot of applications within Industry 4.0. So if we look at asset tracking as the first area, so some of the common use cases here are wearables for tracking people or pets. I'm sure you've seen, if you have pets, cats or dogs, you've seen these collars for tracking them. If they go out of the house, then of course you won't have. But often they also combine with short range technologies, like Bluetooth LE. But if you're in an environment where you don't have connectivity to Bluetooth, then Cellular acts as the connectivity option when you're out in more in environments where you don't have other solutions. Workplace safety, so tracking people in for example a construction site. Pallet tracking, so you have a cargo that's coming from one side of Europe to the other side, and you want to track it along the way. Geofencing that sometimes kind of couples with the tracking on wearables for people and pets, or tracking vehicles, portable medical devices. You can sort of extrapolate into any kind of industrial or commercial device or equipment that is typically costly, and therefore you want to track it and know its position at any given time. So what does Cellular IoT bring here? So of course, the global coverage is really important for asset tracking, especially for tracking cargo across countries, across continents. Future-proof, you want to deploy a product that can be used for 10 to 15 years out in the market without having to be concerned about the connectivity. High throughput on devices that require location data to be updated very often. Or ultra low power if you don't have that requirement. So it can be, on one side, you might want to track something, every second or every 10 seconds. And on the other side, there's something you might want to track just, once every hour or once per day. So you can sort of balance those things because you don't have to choose one or the other. And then in the NRF Connect SDK, we have ready-made asset tracking applications that you can use as a reference to get started. And also on our NRF Cloud, we have location services that can help you extract or pinpoint your device based on the cellular connectivity. Also on what kind of, we can couple that with the capability that we have for Wi-Fi SSID based locationing. And then all that data gets sent out to NRF Cloud. And then based on that, you'll get a dot on the map and sort of an accuracy estimation. So we actually provide sort of a full solution when it comes to asset tracking from hardware, software, including the cloud services piece. Then on smart cities, some common use cases, waste management. So, for example, deploying sensors on trash bins and knowing when they're full, so that when you send out the trucks to take out the trash, they only go to those that are above a certain threshold, and they don't go to the ones that are not yet full. So you sort of optimize the route space on that. Smart street lights to make sure that you only use them when needed, so you kind of do some energy savings on there. All kinds of environmental management, water level sensors and these kinds of things. Device maintenance, smart parking, and some of the benefits of Cellular IoT, leveraging existing infrastructure. I mean, we're talking about, smart city urban environments. There will be plenty of cellular infrastructure that to be leveraged so that you don't need to deploy your own. And actually, when it comes to LPWANs, and there's something that we heard from customers that decided to go with cellular is that sometimes you do make your own LPWAN deployment, including the infrastructure, and it works for a certain period of time. And then someone else does the deployment, and then you start having interference, and that's where things a little bit go south because you don't have control over this, right? And because it's operating on the unlicensed spectrum, there's no assurance of that these different networks will not interfere with each other. So it might sort of create problems further on throughout the life cycle of the product. The coverage, indoor and outdoor. I mean, some of these smart city applications will not always be outdoor. Some of them will be in basements, inside buildings. So you want to make sure that you can reach those from a radio perspective. Being future-proof, so making sure that they will work throughout the lifespan. Having high throughput and low latency, so you can also reach those devices when you need to. And ultra-low power. Then on smart metering, some of the common use cases there are, water, electrical, or gas metering, and also in agriculture to make sure that resources are used without, in a controlled way, let's say. Some of the benefits there: ultra low power, again, the coverage, being able to cover both urban and rural environments. Flexible SIM solutions. What this means is that a solution that Nordic has introduced recently is a software SIM. Which means that it's a purely software implementation of a SIM card, which means you can have more compact designs because you don't need to have the tray for the physical SIM. And also there's some benefits on the power consumption piece in certain operations where the SIM can also draw current. So you eliminate that and have a software only based solution. And also we have some ready-made applications here for metering use cases, including the Internet of Cloud services that you can use there. And then the last application area is Industry 4.0. A very strong use case, which couples with machine learning, is predictive maintenance. So essentially deploying sensors in equipment and being able to read out things like vibration, temperature, humidity, and then having machine learning models running at the node. So the device that you actually have attached to your equipment, that will be able to predict when the equipment starts to sort of shift into a operation spectrum where you might start to see issues, and therefore you might want to maintain it before those issues arise. And if you're thinking about, for example, a production line, you definitely don't want that to go offline. So you want to maintain your equipment to make sure continuous operation. Smart grid, grid balance. And then some of the benefits there: global coverage. The security piece is really important in the industrial setting. So you have reliability and secure connection between your devices and the internet. The scalability piece, that you can start with a pilot and then you deploy more sensors over time without having any issues, and being cost-effective solutions. So all that was, let's say, generic information about Cellular IoT. And let's now shift gears into what Nordic has to offer in this space. So Nordic has a complete solution for Cellular IoT. And what we're trying to do is to make sure that customers can go to market as quickly as possible using our solution. So starting on the left-hand side here, we have the certified hardware and the stack. So we have the SIPs, the NRF91 series, and they have the certified connectivity stacks and the modem firmware. So all of this is pre-certified with the carriers, which means that you don't need to worry about any of that. You just use the products and you deploy your devices out into the field. Then, of course, you need to develop your application on top, your unique differentiation. So for that, we have the NRF Connect toolchain. Within that, there's the NRF Connect SDK, which provides all of the the middleware and utilities that you need, whether it's TCP/IP stack, CoAP, MQTT, lightweight machine to machine. All of that is built into the NRF Connect SDK, and you just develop your application on top of that. Then we also have extensive software and hardware development tools. For example, to measure power consumption, we have a device called the Power Profiler Kit 2. We have a tool called Cellular Monitoring, which allows you to sort of get a log of the cellular activity. So if you have any issues, you will want to use the cellular monitor to log that activity, and then you can go to DevZone and provide that to our tech support so they can help you troubleshoot the issue you're having. Which kind of brings me to the last part here on this diagram, on the left side of the diagram, which is our support. So Nordic is known for having world-class support. We have an online development platform called Dev Academy that has a variety of courses to get started with the SDK, and there's also a Cellular IoT dedicated course. So if you're just getting started, whether you're getting started with Cellular IoT or whether you've been using Cellular IoT and you want to get started with Nordic, this is the place to go. To really accelerate your learning curve there. Then DevZone for support. And because there are things that Nordic cannot provide, I mean, if we're talking about, for example, antenna design, then we have an extensive partner program that can help you create your device, including all the bells and whistles and all the tweaks that you need to do. You can always refer to our design partners on the areas that you might need a little bit more assistance with. So that takes you to your device, and then we have the NRF Cloud providing the lifecycle services to allow you to deploy and maintain your device faster. So device management services, location services, secure identity, and provisioning. So this allows you to provision your devices out in the field through NRF Cloud and also firmware over the air. So if you sort of think about how Cellular IoT or Cellular has been traditionally developed, normally it's sort of a piecemeal approach. So you get multiple components from multiple vendors. You'll have a host MCU for your application, an RF front end, then the Cellular module, if you need location, GNSS module, secure element to store your credentials and your keys, and then a PMIC to do the power management of all these devices. What Nordic has done is to put all of this into one integrated SIP. So all of the parts that you saw earlier are integrated into this one SIP device. So you essentially, the goal here is to lower the cost of the solution and to simplify your supply chain. Because in the traditional approach, you will have, with each of those components, you'll have sort of a different vendor behind it, which gives you fragmented ownership. So your supply chain, your BOM has more lines, but also, if you run into issues on the field or even during development, it will be a more complicated thing to solve because often you have to talk to, for example, a module vendor, but the module vendor is not the chipset vendor. So then the module vendor needs to talk to the chipset vendor. And then, sometimes there's a bit of back and forth on where the issue is. And this, all of this delays the actual time to resolution of, whatever issue you might be observing. Whereas on Nordic's side, because we have full solution ownership, Nordic is the only contact point and everything will be done in-house. So the NRF 9160 SIP, which was the first device we put out into the market, it's been out for 5 years now. It lowers the complexity of your design, gives you lower power consumption, smaller size, so you can do more compact products, and we'll see a few examples in just a minute. And then, of course, lower cost, simplified supply chain, and it's a globally certified product. So one product that you can use on your devices that you will be able to ship globally. A few examples, and these are two examples that are really only possible with the NRF 9160. So the first one here on the top is a animal tracker. It only weighs 2.5 grams, which is quite impressive. And the reason why they picked the 9160 is because it's the lightest and the smallest LTE modem on the market. And because it includes also the application processor, it does not require any extra microcontroller. So it simplifies their design, allowing them to do a really compact solution. And then we have this meter here, That was the goal when they moved to Nordic solution, was to reduce costs, because they were able to strip down a lot of components, use our integrated solution, and reduce their cost by 50%. So that is quite an achievement to be able to lower that cost with one redesign. So let's talk first about the NRF9160. So it is a ARM Cortex M33 based. It has the application processor for your user application. That's why you don't need an external host. And for that application processor, you also have dedicated resources: 1 megabyte of flash, 256 kilobytes of RAM, and it has ARM Trust Zone to provide the isolation between the trusted and or the secure and not secure processing environment. It's a multiband, so the modem supports both LTE-M and NB-IoT, and it has a GNSS as well, including the power management IC and RF front end, passives and crystals. Operation when it comes to voltage from 3 to 5.5 volts and minus 40 to 85 degrees Celsius. So it's ultra power device. Average in EDRX with an interval of 81 seconds is 18 microamps. So this translates to really long battery life. PSM floor current 2.7 microamps. And when it comes to development hardware, there are two choices. You can use the NRF9160 development kit, which is this one here with a blue PCB. And you also have the Thingy91 for prototyping. So the Thingy91 is a prototyping platform that has a built-in rechargeable battery. It has a variety of sensors, so that you can actually use this for sort of field trials and more advanced deployments without having to create your own hardware. So the 9160 is our most mature device. It has been in production since 2018, and we're fully committed to support it long term and to make it available. However, the last release of the modem firmware, which was release 1.3.5 that we had, I think mid last year, this was the last planned release where we have new features. We'll continue to make maintenance releases throughout the NRF9160's lifetime, but there won't be new features coming into this device. However, when it comes to the NRF Connect SDK, that will continue to be supported in new versions of the SDK. So you can leverage new features on the SDK side, which are decoupled from the modem firmware version. So you'll always have access to new features, improvements, fixes, as new versions of the NRF Connect SDK roll out. Then we have the NRF9161. So this is the device that was announced in June last year, and it was launched in January this year. So this is now available out in the market. And I'll just actually run through these quickly. It's very similar to the NRF9160, and we have the differences in blue here. So I had already mentioned this early in the presentation, that the NRF9160 was 3GPP release 13. With a few features from 3GPP release 14. The NRF9161 is fully compatible with the 3GPP release 14. It also brings supports for DECT Plus, and it adds 2 new bands for Cellular, band 65 and band 85. And it has its own dedicated development kit, so the NRF9161 DK. Then we have a device that we just recently announced around 2 weeks ago, the NRF9151. So this is a device that it's still similar to the NRF9160 and the NRF9161 that came before it. But the key differences are, well, first of all, it has to do with the manufacturing. So this device is now manufactured following our own Nordic supply chain resilience strategy. It has a smaller form factor, which is something that is really impressive, how we can still make our devices smaller, given the fact that we're not removing any functionality. So it still includes the PMIC. It includes the RF front end, which is Nordic designed, passives and crystals. And all of this is coming in a footprint that's 20% smaller compared to the NRF9160, although it has a small increase of 0.1 millimeters in height. And it also brings support for class 5 power output. So the previous devices are offering class 3, which is 23 dBm, and now the NRF9151 brings class 5 20 dBm support. So This translates into, in very practical terms, you get 40% lower peak currents. So, and when it comes to product design impact, of course, you will have, less demanding requirements when it comes to battery selection. So you'll have a wider options when it comes to battery selection, because the supply requirements will be a bit relaxed due to these lower peaks. And also very important is that the nRF9151 is fully compatible with the nRF61 when it comes to software and tools. What that means is that if this is a device that's interesting for your application, you can get started today with the nRF9161. And then when the nRF9151 becomes available, you can essentially just rebuild your project for the new target, and seamlessly shift from the 61 to the 51 to continue your development, or even go for your custom hardware design and being closer to a production deployment. The last one is the nRF9131, what we call a mini SIP. This is a lower integration module, so it's not certified. It also has size and height reductions compatible in terms of feature software with the nRF91 SiP, just like the nRF9151. And it is really the best fit that we have for DECNR Plus and for high volume cellular products. The reason being that because it's not pre-certified, it means that the customer has to do the certification. So, and that is something that typically only pays off if you have really high volumes, where you can sort of dilute that certification cost over a large volume of devices. But you're not alone in this journey, because Nordic provides a full reference design and a bill of materials that you can use for your certification process. So as you can see here on the diagram, essentially you get the same features, but the things that are external to the SiP are the PMIC and then the passives and crystals. So these are things you have to implement outside of the nRF9131 in your custom hardware design. Yes, so, but as I mentioned, for the certification piece, Nordic provides a reference, and the goal here is that, through your own certification, to reduce the risk, the cost, and the schedule of your own certification path, when compared especially with a traditional chipset design for cellular. For development hardware, we have the nRF9131 evaluation kits for proof of concept, and if you want to get started with the 9161DK, similarly to the nRF9151. So the nRF9161 is available today. The nRF9151 and nRF9131 are going through the sampling phase. So if you're interested, I encourage you to contact our sales to see whether there's an opportunity to include you as part of the sampling program. So we're starting to wrap up the webinar. So let's just now summarize the top benefits of the nRF91 series devices. The lowest power. So they've been designed with lowest power in mind. That has been in Nordic's DNA for many years, for decades. What this means is that it's not just about we talked about floor currents. It's not just about that. We basically looked at how do we optimize our devices overall when it comes to radio wake up periods, all kinds of efficiencies that could be done. We implemented them, making it the lowest power cellular IoT solution out in the market. And we also provide you the tools to be able to measure and verify that. Then the security is really important. So the nRF9160 is PSA level 2 certified. We have the nRF Cloud Security Services that can get you from a blank device to a securely connected device out on the field, and the reduced cost of ownership with this integrated solution that we have. Simplifying your supply chain, simplifying your manufacturing, and then we have, of course, the tools in the SDK allowing you to focus on your application, get to market faster, and maintain your products throughout their lifecycle. And with that, I think we can move on to the Q&A, and let's see what questions have been coming in during the webinar. Let's try to address as many as we can. All right, so there are questions on the chat. We'll take those as well. Preferably they should go into the questions box, but it's okay. So let me see here. Someone asked about the presentation. You can actually find that available in the webinar interface just under the question box on the top right. There should be a file there which is the PDF export of these slides. And there are some technical questions that I don't really have the answers for. One of them is asking what types of L2 UDP flow control can be used with the NRF Connect SDK API. I would recommend to ask that on DevZone. I don't really have the answer for that one. Another one is how to utilize the LTE-M channels most effective, highest payload or power usage ratio if PSM and EDRX are not used. I think you probably will get proper answers to these on DevZone. Then one question about DECT Plus, actually two questions about DECT Plus. The first one is, when can we test NR Plus on the NRF 9160? So the 9160 does not have support for DECT NR Plus. It's only the newer devices, the 61, the 51, and the 31. And then the other question is, how do we, when will we have DECT NR Plus modem firmware for the 9161 available? So today what we offer at Nordic is access to the file layer, and we have a basic API. To get access, you need to contact our sales, and they will get in touch with a solution partner if you also want a full DECT Plus stack on top. So that would be someone like, for example, Wirepass. They have a full DECT Plus stack running on top of our NRF 9161 device. So, short answer is that you need to get in touch with sales to get access to that. Then how do I choose between NRF 9160 and NRF 9161 for new design? So the NRF 9161, as we mentioned during the webinar, has support for the 3GPP release 14. So it has newer features, and it will get also, it has a different modem firmware. So it's a new version of the modem firmware, version 2.0 and onwards. And it is today in volume production. So, that is the most future-proof solution, especially if you're starting a new design today, because you have, a set of features that's compatible with a more recent standard. But if for some reason you don't need those newer features, you can also select the 9160. So that device, we're fully committed to maintain it. And, it is feature complete, proven solution out in the field. And we'll continue to maintain the modem firmware, just not with new features. It will just have, fixes as we need to roll those out. A few questions on roadmap that we cannot really comment. One was asking about plans for covering lower frequency bands like B31, and the other one are plans for NT or non-terrestrial networks. Unfortunately, we can't really comment on roadmap. Question about reference designs with Bluetooth LE. So if you look at the kits, so the NRF 9160 and the Cellular kits, they do have they also have a NRF 52 part. So I think there's actually even a application that you can do a Cellular or Bluetooth LE to Cellular gateway. So that would be a good starting point there. A question about if PSM mode is suitable for smoke sensors. Hard to tell without knowing more of the requirements, but from the top of my head, I don't see any reason why this would be a problem. I mean, I guess smoke sensors will be the part that will be active the most time is the actual sensing capability. And whenever something is detected, I guess the purpose of adding cellular is that you can get direct connection to rescue services. And you can wake up from PSM and immediately send data back to the cellular network. So you should have really low latency here. And of course, PSM gives you the long battery life that I guess you'd be looking for on a smoke sensor. So I think the short answer is yes. At least, just sort of from thinking from the high level how this would fit. Then a question, sorry, about NB-IoT roaming. Yeah, so NB-IoT is was primarily targeted at stationary devices, also because it has better penetration. So normally it's one good use case. But actually the support for roaming, and also I'm not sure if the question is roaming like between networks or countries, but also mobility. So the handover between different cell towers. So 3GPP release 14 offers better mobility support with NB-IoT than release 13. So if you're going back to the question about whether to choose NRF 9160 or NRF 9161, this is, if you're thinking about using NB-IoT and you do need mobility, this would be a good reason to choose the NRF 9161. We also have a proprietary feature in our modem firmware for this enhanced mobility. So if the support is not there from the network side. We have a feature that tries to match that performance very, very closely. But overall, the roaming is part of the NB-IoT, so that is not a problem. It's more about the mobility between cell towers, but there are improvements coming there. So as you can see from the spec itself, but also we're trying to do that better at Nordic's firmware when the support is not in place from the operator. And then a question about IMEI. So I heard that the new NRF91 does have IMEI by default. So the solution needs more process, and it can't just work. So I mean, it just doesn't work out of the box. This is correct. So the NRF9161 comes without IMEI. So this is for the parts. If you get a kit, it does have a Nordic IMEI pre-programmed. So make sure that you can get started with your design and your overall experience with Cellular as quickly as possible. But for the parts, it comes without IMEI. There are two options here. You can either get IMEIs for free through NRF Cloud, our cloud services platform, if you have a Pro or Enterprise account, or you can get those from the GSMA. So this will just add a small step into your production run where you need to issue an additional command to write the IMEI to the device. But there's a benefit here that as a user now, you can choose between having your own TAC range when you get those IMEIs from the GSMA, or you can use Nordic IMEIs when you get them through NRF Cloud. Okay, let me see if there's a few more questions that came in. What was the last one? Is it possible to use GNSS only for GNSS sniffing and solve the location in the cloud to reduce the power consumption? Not sure what it means, GNSS sniffing. So, oh, okay, I see. So I guess it means not compute the location on the device, maybe? I don't know if that's possible. That's probably a question to DevZone. Would you recommend to use PSM and eDirects at the same time? I think this is a bit of a mutual exclusive option depending on your use case, because having them at the same time, I'm not sure that's even possible from a technical standpoint. Maybe on DevZone they might be able to give a better answer to this. You mentioned SoftSIM. Is it supported on any module yet? Actually, SoftSIM is supported on all parts, including the NRF9160. So this is not, let's say, an exclusive feature of the newer parts. You can use it today with the NRF9160. The first SoftSIM or software SIM provider that we're working with is Onomondo. So you need to reach out to them to get the SoftSIM profiles. But this is something that is, it's ready to go into mass production. On your presentation, you mentioned floor currents is less than 5 microamps. How can this be achieved? Well, I mean, these microamp level currents are quite common in, sort of wireless MCU or wireless SoC platforms. Essentially, you shut down everything except the bare minimum. So timers, the bare minimum requirements or features that are needed to keep your device kicking, basically, or reacting when it needs to. So waking up, if you're using PSM, there has to be a timer to know when to wake up and check in with the network again. But sometimes you need more or less accuracy, and depending on the accuracy, you will have higher or lower floor current. That's why there's a difference between PSM and eDirects. I think that's all the questions on the question box. Let me see if there's anything else on the chat. No, nothing new. Okay, if there are no new questions, I would like to thank everyone for joining today. And yeah, we'll see you on one of our next webinars, and have a good day, everyone. So looking here at the questions, okay. So it seems we had 3 questions during the webinar, but if there's something that is still lingering on the back of your mind, feel free and add them to the question box. So the first question is if NB2, so NB-IoT, NB2 meaning 3GPP release 14 supports handover. And yes, there's actually a support or better support for handover on NB-IoT in 3GPP release 14 than on 3GPP release 13. So as a reminder, the NRF9160 supports 3GPP release 13 with a few features from release 14, whereas the other products, the NRF9161, the NRF9151, and the 31 support 3GPP release 14, which means that this is a feature that you will get if you select those products. In addition, we also have a proprietary feature in our modem firmware that provides a smoother handover when that is not supported by the operator. So if that happens, that the operator does not yet have the support in place, then we have a feature that tries to essentially reduce the power consumption penalty, let's say, of roaming on NB-IoT. Okay, one other question is, are the NB-IoT and LTE messages also secured in the cellular core network and on the interface between home and roaming network if the device is in roaming? Yes, they are secured. So there's authentication procedures for roaming, both on the home location register and home subscriber server that will validate the device's identity to make sure that there is continuous security and data validation as they roam. Also, another question related to reliability: is the radio interface for NB-IoT and LTE-M 100% reliable on the IP layer? Well, from engineering standpoint, nothing is 100% reliable, but I would say reliability issues would be at the radio layer. So if there's any, let's say, if you have insufficient signal strength, for example, then will of course lead to issues that will manifest on the higher layers. But one thing to point out is that NB-IoT, the specification doesn't mandate support for TCP. So if you are using NB-IoT and you want to be fully interoperable, then it's recommended to use a UDP-based protocol. For example, CoAP, or Constrained Application Protocol, which is also, we have support for that on the modem firmware and also on NRF Cloud side. So this is a protocol which is much lighter weight than other protocols that are a little bit chatty. They have a bit more overhead. So that's something we definitely recommend customers to look into. And we have a blog on DevZone that makes a comparison from power consumption standpoint between CoAP and MQTT, which is a more widely deployed protocol, but that is based on TCP. Okay, another question: does NRF9161 have Bluetooth built in? No, it's only a cellular device. It doesn't have a Bluetooth capability. When are NRF9151, NRF9131 DevKits and Thingy X expected to be available? So this is a roadmap question. That's not something we will address in this webinar. The only thing I can recommend is that you go to our website and subscribe to the newsletter. You will get notification when these devices will be launched and available to be purchased through our distributors. Is 32 points, so the 32K oscillator included in the NRF9160 SIP? I would have to double check, but maybe I would recommend that you maybe ask this question on DevZone, and I'm sure our tech support team will give you a definite answer. And what kind of peripheral does the NRF SIP provide that can leverage in my application? How many GPIOs do I get for my application? Well, this is something that you will be able to see from the device specification. So if you go to our technical documentation page, docs.nordicsym.com, and then you go into NRF91 and product specification, you'll have the full specification for the device, including GPIOs and the peripheral. But essentially, I don't remember the number of GPIOs. When it comes to peripherals, you should expect to find essentially everything that you find on let's say mainstream microcontrollers. So you'll have SPI buses, UART, I2C, timers, the PWM, these sort of things. So there shouldn't be any surprises there. But of course, something more specialized, it might be that it's not there, but it depends a lot on the use case and the application requirements that you have. And that was the last question. So I think we'll wrap up our webinar here. Thanks everyone who attended. Have a great day, evening, morning, depending where you are, and hope to see you again on a future Nordic webinar. Thanks for coming.